Hello everyone, welcome to Geeks for Geeks, and in this video we are going to do exploratory data analysis and model development using this PIMA Indian diabetes dataset. And in this, first of all, you need to click on this new notebook after you are on this dataset, and you can also see the information about our CSV file. So we are having a CSV file and you can see how many columns are there, what are their importance, how many null values, all you can check from here. But let's do it programmatically and click on this new notebook. A notebook will be created, and now after that we can start our coding. So first of all, let's give a name to our notebook and let's call it EDA on diabetes dataset. And let's clear all this and let's try to start by importing pandas as PD. Let me just increase the font size. Yes, I hope it is visible. And after that, let's import numpy as np, and then let's import matplotlib, which is a data visualization Python library, .pyplot as plt. So this plt, pd, np, they are the objects of these classes. And finally, let's import cbon, which is an advanced data visualization library, and let's make an object called sns. Let's hit shift plus enter and all these libraries will be imported. And over here in the input you can see our data set. So this is the advantage of using Kaggle. You don't need to download CSV files, you don't need to upload CSV file. You can directly create a notebook in that data set and already your database or data set will be visible on the right hand side. So let's copy this diabetes.csv file path and let's try to create data object is equal to pd.readcsv. Data is equal to pd.readcsv, and let's paste the path over here. So I'm writing in the markdown. Let's cut it out. Let's paste it over here. Let's paste the path by copying this, paste it over here, and let's hit shift plus enter and let's try to see what's in our data set, data.head. Yes, so here I can see I have this column name, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, that is body mass index, diabetes, pedigree, function, age, and the outcome. Outcome 1 means that you are having a diabetes, 0 means you are not having diabetes. And this is only we need to predict. And first of all, we will do some data visualization, data analysis, and finally we will do create a model for prediction. And let's try to run data.describe, and using this we can see all the mathematical indications from this data.describe function. We can see how many counts are there. So every column is having 768 rows. Mean, what is the mean? How many pregnancies is the average in these patients? 3.8. like we can take 3 because it will not be in decimals. Glucose 120 is the mean value, 69 is for blood pressure. What is the minimum value in pregnancy? That is 0. And 25%, what is 50? So all this data information you can get from here. So let's try to run another thing which is called data.info. Using this we will be able to know how many null values are there. And okay, I wrote in the markdown. Let's write over here. Yes, so we can see that no null values there, all are filled values because 768 values are non-null, and we are having 768 rows. That means all are filled. No null values there in our data set. So this is a good thing. We can also verify it using let me just delete this cell. Yes, and now let's run data.isna.sum and let's try to run it, and we can see that there is no null value in any of the columns, right? So this is how you can verify it. Now let's try to see how many duplicate values are there in my data set. So for that thing you need to run data.duplicated.sum. Let's hit enter. 0. That means no duplicate row is there, which is also another good thing. So let me just write a markdown over here that this thing is for checking null values, and you can hit Control A and click on this bold, so it will be bold, and hit enter. Same thing, let's do it for here, checking duplicate values, let's make it bold, shift plus enter. Perfect. So these two things that we are now know that there is no duplicate values and there is no null values in our data set. Good. So let's try to do some data visualization. So let me just put a big heading, data visualization H, and this will be a bigger heading. So first of all, let's create a plt.figure, which is a matplotlib figure. So, and over here we can give a parameter called fig size. So what is the figure size? Let's make it 12,6, where 12 is the x values, 6 is the y values, right? So you can just play with these values and you can change the size of graph, right? So figure means a graph, and let's create a seaborn count plot. So sns.count plot. I hope that you already know the significance of these count plots, scatter plots, and all that. So what x value you want to keep? So in the x value, I want to keep the outcome, that how many people are having diabetes, how many people are not having diabetes, and what is the data. So just provide a data parameter and give data. So data is nothing but our data frame that we are currently working on. And finally, let's run plt.show and our graph will be shown. Yes, so over here you can infer that like these many values, around 280 values or patients are having the diabetes and around 500 patients are not having the diabetes, right? So this is the significance of this count plot, right? So let's create another figure and let's observe the outliers. So what are the outliers? Outliers are the values which are not expected or the unexpected values. So let me just put a mark down and let's say observing outliers, and let's make it bold. And for this thing, again, we need to create a plt.figure, and let's give a fig size, and fig size, let's make it square this time. So 12,12, and now we need to run an enumerate function. So I'll run a for loop, because for seeing the outliers, I need to go through all the columns. So I'll use a for loop and I'll iterate through all my columns. So for I comma col, that is col, that means a name for my column, in enumerate, and over here in the square brackets write the names of all the columns. So we can copy from here, first column, then write the second column, and I'll be back by writing all the columns. So now here you can see that I have written all the columns, and after this we need to plot a subplot. So plt.subplot, and let's give a size of 3,3, and my index will be I plus 1, because we can't start from 0. So it will be 0 plus 1, that is 1. And next thing, let's plot a box plot in this subplot. So this plt.subplot is nothing but a space on our main graph, and on that space I'm going to draw a box plot. So box plot is very helpful for observing the outliers. So let me just write, and x will be nothing but my column, and data will be nothing but my data frame. So data, right? And finally, let's run plt.show and let's see what we get. Yes, so we are getting the box plots for all the values. As you can see, for pregnancies, these are the outliers. Like how many, like these are the outliers, you can say, right? Nobody, like not a normal patient will not have above 15 pregnancies, or a normal patient will not have 0 glucose or 0 blood pressure, like, right? So these are the outliers. We need to we can handle these outliers, right? So this was the significance of drawing the box plot, so that you can see how many outliers are there or what are the outliers, right? Now let's create a pair plot, and this pair plot will draw a graph for each column with each other. So let's draw a pair plot, and let's write sns.pairplot. Let's give the data frame as data, and hue means the like on which column you want to show the difference. So it will be on the outcome, and my data will be nothing but my data. So let's run plt.show. Let's run it. Let's wait for some time, because this pair plot has to do a lot of mathematical computations, because it has to draw a graph for every column with each other. So let's wait. Yes, so using this pair plot, you can like go through each and every graph, and you can see the relationship for each column with each other, as you can see over here. So you can see a clusters of orange and blue. That means orange you are 1 means you are having diabetes, blue means you are not having diabetes. And over here you can see a exponential kind of graph, or clusters are there, right? So you can go through all these graphs, and you can like write your predictions, or you can say write your inferences, results, or case studies you can do on these graphs, right? So let's draw another hist plot. So let me just draw a hist plot. So it will be plt dot figure. These are nothing but different kinds of visualizations I'm showing to you, so that you can use these visualizations in any other data analysis or visualization project that you are doing on your own, right? So let's write for I comma column in enumerate. So same thing. So let's copy the same line, and I think we can copy the same code, and we can change box plot to hist plot. So over here, let's change this box plot to hist plot, and I think everything will remain same. But over here we need to also define whether we want the kernel density equation. So let's write KDE is equal to true, and rest everything will be same. So let's run it. You can see like for which range the values are increasing, for which range the values are decreasing. So you can see for 10-15 pregnancies it is very low. That means they are not normal, they are abnormal pregnancies. And for this BMI also from 20 to 40 it is very high, which may be because it is a normal value. That's why most of the patients are having this body mass index, right? So these are the inferences. And finally let's create a correlation heat map. So finally let's create plt dot figure, and let's write fig size is equal to 12, and let's write sns dot heat map data dot correlation function. So CORR brackets comma, and finally we can give the minimum as minus 1.0, and we can give our center as 0, and we can give our color map. So C map is equal to red, then blue, and small red. So finally annotations. So annotations are the values. Do you want to show the values on your heat map? Yes, we want to show. So let's keep it true, and finally give the data as data frame, which is data. So finally let's do plt dot show, and let's run it. And this is our beautiful correlation heat map, and you can see the relationship for the diagonal will be 1 because it is plotted with that column only. Pregnancies is plotted for with the pregnancy, that's why it is 1. And like this you can see the relationship that pregnancies is having a high correlation between age, and glucose is having a high correlation with outcome, age is having a high, yeah, that's the same thing. And this negative correlations also you can see insulin is having a negative correlation with pregnancies and all that, right? So now these were our some data visualization graphs, and finally what we can do is we can start creating our model. So for that, first of all we need to do standard scaling, so that our plots, sorry, so that our data is scaled down and it has come to the same scale, like all the columns are on the same scale. So I'm going to keep a heading over here, and I'm going to give the heading as standard scaling, and also the label encoding. The last column should be, or the string column should be label encoded. So label encoding, and let's keep it bold. And let's first of all import standard scaler from sklearn.preprocessing. Import standard scaler, and let's write sc underscore x, that is for the x values, or we are creating just a object of standard scaler. And let's define our x values. So our x values will be nothing but pd dot data frame. I'm creating a new data frame, and what I need to do is I need to fit my values or my outcome my values apart from the outcome into my standard scalar object. So I'll write sc underscore x dot fit, and I'm going to fit. Yes, over here you can see what I did is sc that is my standard scalar object dot fit transform data dot drop. That means I have dropped my outcome column because x will be all the independent values and outcome is my dependent value. So I've dropped that column, x is 1, and I've taken all those columns. So if you will just see my x, first of all let me just run this, and finally let's run x dot head. You will see that my values are scaled down and outcome is not there, right? Because outcome will go in my y. So what I'll do is I'll create another column named y, or my another data, and this will be just my outcome, and this class needs to be predicted. So this is containing just 10 10 10 kind of that. And finally I need to do train test split. I hope that you already know about that, why we do that. So I'll write from sklearn dot model selection import train test split, and finally after that I'll write xtrain. So here you can see that I have done train test split x comma y, that is my independent values and my dependent value. Then test size is 30%, random state is 0. Let's run it and my data will be split into x and y. So for this diabetes prediction I'm using k-neighbors classifier. So let's import from sklearn dot neighbors, and in neighbors we don't have u, so let's import k-neighbors classifier. And finally we need to create two variables, test scores. It will be a list because we need to see for which all parameters we are having the best predictions, and my train scores. So depending on the scores we will choose the parameters. I hope that you already know about k-neighbors classifier. And finally what we need to do is we need to run a for loop. So for I in range, so here we are like finding the best nearest neighbors value, right? And let's take it from 1 to 15, and let's write knn is equal to k neighbors classifier object, and knn dot fit my x train and my y train. And finally let's print, let's fit train scores dot append, and it will be knn dot score x train comma y train, right? And finally let's write test scores dot append knn dot score x test comma y test. Let's run it. So there is some error, sklearn dot neighbors, okay, there is spelling mistake, sklearn, and one more error, knn dot fit x train argument, one missing required positional argument. Yes, so in the k neighbors classifier we are having I. Yes, this I forgot the main thing, that is which value, how many k neighbors you want to pass. So let's wait. Yeah, this is now working perfectly, and based on the scores let's find the best value. So score that comes from testing on the same data points that were used for training, right? So let's write max train score is equal to maximum from the train score. So let's see which is the maximum value or what maximum scores we got. So let's write, and after that let's write train scores index. So because we want the index, right, from 1 to 15 which value was there. So train scores index is equal to I for I comma value, that is v, in enumerate. So I hope that you already know about enumerate function. That's a basic Python function. Train scores if my value, that is v, is equal to my max train score. So what I'm doing is I'm finding the value for which my maximum score has come. From 1 to 15, what was that k neighbors for which I got my maximum train score? And now let's try to print the maximum train score. So print max train score, and we will use the format function percentage, and for which k I got this value. So again format, and we use single brackets, sorry, let's use double only, and then we will use dot format max train score into 100, because we want to print a percentage, into 100, comma list, and I'll map. And for writing a single line function, you already know that we use lambda functions. So lambda x plus 1, because we were starting from 1 to 15, that's why. So x plus 1 comma train scores index, comma train scores index. Yes, let's print it. So what is the runtime object has no attribute format? Okay. Yes, we just finished this thing. So it will be like this, and like unexpected, yes. So we did not close this out. Yes. So we can see that maximum training score is 100% and it is at k is equal to 1. So for finding the best model, or for creating the best model, we need to take k nearest neighbor value as 1, right? So finally, let's also see the testing scores. So I'll do the same thing over here. So this tutorial is based on k nearest neighbor for finding the best k value, and for creating a plot also. I'm also going to create a plot so that it will be very much clear to you. So maximum test score is equal to test scores. We will do maximum from test scores, and let's make it test scores index. Test score index will be from the test scores, not from the train scores, and it will be maximum test score. Perfect. And maximum test score we will print, and this will also become maximum test score percentage, and this will also become test score index. Let's run it. So maximum test score is 77.9, that is around 78%, and it is for k is equal to 13, right? Now let's plot it. We are just finding the k values, but we don't know how is it coming, right? So let's create a plt.figure, and fig size, let's keep it 12 comma, we need 12,5, and let's keep p is equal to sns.lineplot. sns, I hope that you already know about cbons and matplotlib functions. So we are having this line plot, and range from in the x what we want, 1 to 15. So because we took the range as 1 to 15 while finding the k values. And for first plot we will be having train scores. So it will be train scores, the complete list will be printed. What is a marker you want to do? So marker will be a simple star, and finally the label is equal to train score. That's just the axis name, so train score. And finally let's also do the same thing for the testing score. It will be same test scores, marker let's put it O, and label will be test score. Let's print. Yes, so here you can see that this is my training scores and test scores. For training score, for the blue line, I'm seeing that at 1 only, right? At 1 only I'm having the best 100% training score, and after that it is decreasing. But for testing, the value is maximum at 13, right? You can see this is the highest point for orange line, this is 13, right? And we got the same thing, 13. So that's why my testing score is highest at k is equal to 13. Now using this k values you can create your model. So let's try to create that. So first thing what we need to do is we will create another object of k nearest neighbor. Sorry, k nearest k neighbors classifier it is, not k nearest neighbor, k neighbors classifier, and we will pass my k as 13 because we got the best testing score there, and knn dot fit my x train and my y train. Perfect. And finally let's print our score, knn dot score x test comma y test. Let's print 77.9%. Checking the model performance. So let's check the model performance by using metrics. So import sklearn dot metrics, import confusion matrix, so that to find how many values are correctly predicted, how many values are false positive, false negatives, right? It will be matrix. And finally let's find y predicted is equal to knn dot predict for my x test values, and finally my confusion matrix will be between my y test and my y predicted. And yes, so let's run it. Confusion matrix, okay, from sklearn.metrics, yeah, let's run it. Yes, so this is my value for confusion matrix, 141 and 39, that is my diagonal values. They are correctly predicted, that are true positives and true negatives. 16 and 35 are false positives and false negatives, right? So these are the false values, but rest values are correctly predicted. Perfect. Finally, let's just print the classification report and we will be done with the day. So sklearn dot metrics only, import classification report, and let's print classification report between my y test and obviously my y predicted. Yes, so let's print it. Yes, so this is my precision value, recall, F1 score and support. So I hope that you already know about these values. What is the significance? For precision for 0 is 0.8, precision for 1 is 0.71, accuracy is 231, that is support. Support is 231. And yeah, so this is my macro average, this is my weighted average, right? So these are my values. I hope that you like this tutorial, and if you have any doubts you can put the doubts in the comment section, and thanks a lot.